Hello everyone, this is Dr. Mihir Shah once again with another video. In this video, we are going to learn how to solve problem sum based on linear programming problem, also known as LPP. In this video, we are going to basically solve LPP under the method called as formulation, also known as tabular. Okay. So let us see how to solve the sum based on LPP formulation method under the subject operation research. Again, a very important topic from all the TY, BMS, M6 student. In this video, basically we are going to take up 4 sums. 2 will be based on minimization problem and 2 will be based on maximization problem, having 2 constraint and 3 constraint. So let us start with the video and see what are the different types of sums that you can get and how you need to solve them. So let us start with sum number 1.
Okay, now let us see the very first sum based on LLP tabulation method or formulation of LLP method. Okay, now the question reads out as: a person makes 2 types of gifts A and B. It requires the service of cutter and finisher. Gift items of A requires 3 hours of cutters and 3 hours of finishers, whereas gift item of B requires 3 hours of cutters and 5 hours of finish time. The cutter has 250 hours and fisher has 200 availability of time on every month. Profit per unit of A is rupees 35 and B is 45. Formulate LPP. Now, whenever you get such kind of sum, the very first thing you need to identify whether the sum is based on maximization or minimization. So, very simple trick. In the question, if you see the word profit, remember it will always be maximization sum. If there is cost, it will be minimization sum. Okay, remember we always try to maximize the profit and minimize the cost. So in this sum you can see in the last statement is given that profit per unit. So it's profit related. It means it is related to maximization sum. Okay, that's the first thing that you need to understand. Second, now check what are the 2 prominent goods, 2 prominent variables which are given to us. So I can see here a person makes 2 types of gifts, that is gift A and gift B. So always remember, make a table like this. Okay, we will have gift A. So now there are 2 things here, so I'll write here this is related to gift A and this is gift B. Okay, so there are 2 types of product, gift A and gift B. After that, it reads out that it requires the service of cutter and finisher. So now there are 2 types of services in this. One is based on cutter, one is based on finisher. So first, always remember note down first 2 products and then the other variables which are given to that. After that, given that gift A requires 3 hours of cutter. So these are all in hours. Okay, so these are hours, these are hours. So very simple now. Gift A requires 3 hours of cutter. So I'm writing here as 3 and 3 hours of finishers. So I'm writing here 3 here also. And then it's given that gift B requires 3 hours of cutter and 5 hours of finisher. The cutter has 250 hours and finisher has 200 hours. Okay, so availability. Now remember here one thing. They said for cutter the maximum hour which is available is 250. Remember, if this sum is based on maximization, so for maximization it will always be less than equal to, this is basically a constraint that you are writing. Okay, less than equals to, for cutter it is 250 hours and for finisher the availability time is 200 hours. So this is like a constraint that we are writing. Always remember, for maximization it will always be less than equal to. After that, okay, after noting that, the next thing what we need to note down is the function, the main function, whether it is based on maximization or minimization. So I'll just note down one more column here. Okay, so this is based on profit. So I'm writing here profit is going to be, they said, For A it is 35 per unit, and for B it is 45 per unit. This is it. This is all which was available from the question. So now let maybe write, let the number of units manufactured be, this will be called as x1 and the second one will be called as x2. This is our tabulated form. Okay, so we noted on there were two products, there were various services, so we noted on the services. Okay, after that we have written the values which were given to us based on the question. Okay, now remember these steps. Okay, you have to just follow 3 steps. In 3 steps you'll be able to complete the entire sum. The very first thing is called as, we'll have to note down something called a decision variables. Okay, decision variable meaning your x, what are you naming as x1 and x2? So we'll write here x1 equals to gift A and x2 is equal to gift B. That's the first thing. Second thing is called as objective functions. Objective function means whether the sum is based on maximization or minimization. Now since I told you in this question they are talking about profit, so profit is always maximizing, so I'll write here maximize Z equals to, now here is given 35, so 35 is for x1 and 45 is for x2, so 35x1 plus 45x2. Third, it is something called as subject to constraint. Subject to constraint. Okay, here we have to note down the equation. Okay, now we are going to convert this and this line into equation. So it will become 3x1 plus 3x2, okay, less than equals to this is 3x2 less than equals to 250. Second equation would be 3x1 plus 5x2 is less than equals to 200. So we are converting this into equation. And last we have one non-negative equation whereby we just have to mention that x1, okay, comma x2 will always be greater than and equal to 0. Okay, so first we have to note down decision variable, second objective, third subjective constraint. Final answer, therefore LPP can be formulated as max Z is equal to 35x1 plus 45x2 subject to constraint three x1 plus 3x2 is less than equals to 250. 3x1 plus 5x2 is less than equals to 200, and x1 comma x2 is greater than or equal to 0. That's it. This is how you all need to solve the sum based on LPP based on formulation. So this is tabular formulation. Whatever data was given, we have to make it in table form. Decision variables will be x1, x2 and name it as per whatever product you're giving. Then subject constraint will be either maximization or minimization, subject to constraint, and then finally you're going to just formulate the LPP. Okay, so this is how you all had to solve the sum based on LPP. Now this was maximization sum having 2 criteria. Okay, now we're going to take up a sum where it will be again based on maximization but having 3 criteria. Okay, chalo, let us see that sum. Okay, now let us see the second sum. Okay, a manufacturer produces 2 different models X and Y of the same product. So we have product X and product Y. So I've noted down that the product X makes a contribution of 50 per unit and model Y 30 per unit towards the profit. So now this is related to profits. Okay, so again, if it is a profit, it is a maximization problem sum. Okay. After that is given that the raw material R1 and R2 are required for the production. So here we have R1 and R2 are required for the production. At least 18 kg of R1 and at least 12 kg of R2 must be used daily. So that's like the maximum limit. Okay, that's the maximum limit or availability. Since it's maximization, so less than or equal to, they said R1 kilo it's 18 and for R2 it is 12. Okay. Next, also at the most 34 hours are to be utilized. Okay, so also they are giving you that something 34 hours needs to be utilized. Now quantity of A requires 2 kg of R1 and X1 requires 1 kg of R1 and requires of Y. So they are giving you details. For each of X and Y, 1 kg of R2 is required. It takes 3 labor. So now they are even giving you labor hours. Okay, so the third one is related to labor. Okay, and they said at the most 34 hours are to be utilized. So less than equals to 34 hours are for labor. Labor is in hours. Okay. Chalo. So now so this is basically, so we have here 3 constraints. Okay, we have 1, 2 and 3. After that it's related to profit, so I'll note down this as profit. Now from the start, model X makes a contribution of 50 per unit, so profit is 50 for X and for Y it is 30. Okay, and I will write here, let the number of units manufactured be, this will be X1 and this will be X2. Chalo. Now let us just fill all the details of our constraint. So here it is given that in the question at least 18 and 12, we have already done that. Okay, so we start with a quantity of 2 kg of R1 is required for X and 1 kg of R1 is required by Y. So I wrote here 2 and 1. Thereafter for each of X and Y, 1 kg of R2 is required. So 1 kg of R2 is required. Then it takes 3 labor hours to manufacture X and 2 labor hours to manufacture Y. Formulate LPP. Okay? So we have completed with our tabular form. Now we will start with the solution. So number 1 will be always decision variables. So decision variable will be, we'll say let X1 equals units of X, unit of product X, and X2 will be unit of product Y. Second, we have objective function. Okay, since it is a profit related, so it's a maximization sum, so we write max Z equals to 50x1 plus 30x2. Third, subject to constraint. Okay, we have 2x1 plus 1x2 less than equals to 18. So next 1x1 plus 1x2 is less than equals to 12, and for labor it is 3x1 plus 2x2 less than equals to 34. And last, non-negativity, x1 comma x2 will be greater than or equals to 0. Once we have done that, now we can write therefore LPP can be formulated as max Z equals to 50x1 plus 30x2 subject to constrain 2x1 plus 1x2 is less than equals to 18, 1x1 plus 1x2 is less than equals to 12, and 3x1 plus 2x2 is less than equals to 34, and last x1 comma x2 is greater than and equals to 0. Okay, so this was the second sum based on maximization having 3 criteria. Okay, so we have completed here with 2 maximization sum. Now let us see the third sum, how it will be based on minimization. Okay, what kind of sum you can get based on minimization. Okay, now let us read the third question. Nutrition N1 and N2 are required by 2% P1 and P2. So now there are 2 persons here, and 2 nutritions are given. So it's basically 2 by 2 base. So first let us draw the table, and then we'll see how to post the values. Okay, now let us read the question once again. Nutrition N1 and N2 are required. So we have 2 nutrition or 2 types of product here, N1 and N2 are required by 2 persons, P1 and P2. 1 unit of P1 is given. 1 unit of P1 contains 4 units of N1 and 6 units of N2. So it's saying 4 units of N1 and 6 units of N2, whereas 1 unit of P2 contains 5 units of N1 and 4 units of N2. The minimum consumption, now they are giving you minimum consumption, so min consumption. The minimum consumption by nutrition by P1, now it is minimum. So if it is minimum, so it will write greater than and equals to 65 for P1, and P2 it is 85, so greater than equals to 85. Now the cost per unit of P1 and P2, now see again, now this is related to cost. Now always remember, if it's a sum is related to cost, it will always be minimization. So here I will write cost. The cost of unit of P1 is 8 and that of P2 is 6. Okay, now I'll write here, let the number of units manufactured be x1 and x2. Okay, so again now we'll start with the number 1. First will be see, the solving is same. It's the only thing, it will be greater than, and this is based on your cost. So here it will be first point, decision variable. Our decision variable will be x. Let x1 be n1 and x2 will be n2. Second, objective function. So now this is based on cost. So cost it will always be minimization. So minimize z as 8x1 plus 6x2. Third, subject to constraint. So subject to constraint will be 4x1 plus 6x2 greater than equals to 65. 5x1 plus, from here, okay, these are the 2 constraints. 4x2 greater than equals to 85, and last one we have non-negativity ke liye, so we'll have x1 comma x2 greater than equals to 0. Once you have done that, the same stuff, therefore LPP can be formulated as minimum z is 8x1 plus 6x2 subject to constraint 4x1 plus 6x2 greater than equal to 65, 5x1 plus 4x2 greater than equals to 85, x1 comma x2 greater than equals to 0. So solving is exactly same for maximization or minimization. The solving part is exactly the same. Okay, the only thing you have to remember, this will become greater than, this is cos, so here we will have minimization z. Okay, so this was minimization sum where we had two constraints. Now let us check with the last sum that we are going to do, where the sum will be based on minimization and we'll be having three constraints. Okay, so chalo, let us see the run. Okay, now sum number 4, we'll read the question once. A diet conscious housewife to ensure certain minimum intake of vitamin A, B and C for the family. So here they have given you three criteria of A, B and C. Those are the vitamins which are required. The minimum daily need of vitamin A, B and C for the family are given to us. For the supply of these minimum vitamin requirement, the housewife relies on two fresh food, that is F1 and F2. So we have F1 and F2, two types of food, and we have three vitamins A, B and C. Okay, and they are giving you the minimum daily need. So minimum need I'm writing here. The minimum need is 30, 20 and 16 units. So since it's minimized, it will be greater than and equals to 30, greater than equals to 20, greater than and equals to 16. Okay, for the supply of these they require two food F1, F2. F1 provides 7, 5 and 2 units of the three vitamins per gram. So 7, 5 and 2, and F2 provides 2, 4 and 8 per gram. The F1 cost, again it is based on cost, so it will be a minimization sum. So cost of F1 is 3 per gram and F2 it is 2 per gram. So let the number of units manufactured be x1 and x2. Okay, chalo. So now we have our table with us, so we can start. Number 1, decision variables. So we'll say let x1 be f1 and x2 will be f2. Second, objective function will be for A. Now there are no, so this is based on cost, so it's a minimization. So minimization z is equal to 3x1 plus 2x2. Third, subject to constraint, we have 7x1 plus 2x2 greater than equals to 30. 5x1 plus 4x2, this is the equation. Okay, we are forming equation of the constraint, greater than equals to 20. 2x1 plus 8x2 greater than and equals to 16, and non-negativity x1 and x2 has to be greater than and equals to 0. Okay, so once you have done this, now I can finally write, therefore LPP can be formulated as minimum z is equals to 3x1 plus 2x2 subject to constraint 7x1 plus 2x2 greater than equals to 30, 5x1 plus 4x2 greater than and equals to 20, 2x1 plus 8x2 greater than and equals to 16, and last x1 x2 are greater than and equals to 0. Okay, so this is how you all had to solve the sum based on LPP, the formulation method or tabular method. Okay, so I hope everyone have understood this. We had taken 4 sums having 2 maximization, 2 minimization. Okay, both having each of 2 constraint and 3 constraint. Okay, so I hope everyone have understood that. With that, we will be ending this video here. Thank you.